So now let's take a look at the rest of the primary trig ratios and see how we can use them in order to solve for missing angles or sides. Now, this word may seem a little funny to you. It's actually, we say Sohcahtoa is how we pronounce it. Sohcahtoa actually stands for the three primary trig ratios that we're going to be using. We'll start here. This is the one that we actually know. Tan theta is equal to the opposite side divided by the adjacent side. And so that gets abbreviated as TOA. Tan equals opposite over adjacent. All right, but let me introduce to you the other two primary trig ratios that we can also use, depending on the information that we're given. All right, so beginning with the tangent ratio from before, determine the length of Q in the triangle shown. And so let's begin. We have the angle. I'm going to label my side. So Q is opposite, 21 is adjacent, and of course, across from the 90 degrees is our hypotenuse. Since I'm looking for my opposite, have my adjacent, I'm going to use tan. And I say tan of 71 degrees is equal to Q over 21. Now remember, we're going to cross multiply this. So I'm going to put this over 1. And then let's do some multiplication here. And I get 1 times Q, which is Q. And then 21 tan 71. Notice I put the 21 first because if I put it at the end, if I wrote it as tan 71, 21, you may get confused and think of that as 71 times 21, which it is not, right? So, of course, just to keep it cleaner, we put it at the beginning. All right, so calculator time. In your calculator, you want to, again, make sure that you are in degree mode. It should have a D at the top for degree mode. And then from there, you would type in 21 tan 71 and hit equals. And when you do that, you get approximately 61 degrees. Oops, not degrees, 61 units, whatever this is measured in. So the length of Q is 61 centimeters or meters or whatever we're talking about. Good. Okay, so there are three important ratios that we use in trig, and it all comes with depending on the information that we're given. So let's say we have this angle theta down in the right left-hand corner. Then directly across from it, of course, is our opposite side. Beside it is our adjacent side, and directly across from the 90 degrees is our hypotenuse. And so depending on the information that's given, we can use either sine. So take a look on your calculator, see if you can locate the sine button. So sine alpha is equal to the opposite over the hypotenuse. Cos alpha is equal to the adjacent side over the hypotenuse. And tan alpha is equal to the opposite over the adjacent. So these are our three primary trig ratios. And we memorize them by using the abbreviation of Sohcahtoa. And that reminds us that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. All right, so this just comes with practice, figuring out which one we're going to use. So here is an example. We have our triangle. And we want to solve for side G. So the first thing you do, first step, is to label your sides. So label sides. So this would be my opposite side. This would be my adjacent side. And this would be my hypotenuse. My next step is to decide on the trig ratio that we're going to use. And you do that by simply looking at your information that you're given and what you're looking for. So in this case, we have an angle. We're looking for our opposite side, and we have our hypotenuse. So if I think about Sohcahtoa, which one of these has an opposite side and a hypotenuse in the primary trig ratio? Opposite and hypotenuse, so you're probably thinking it's this one. There's my opposite, there's my hypotenuse. So we're going to use sine. Sine 75, because that's my angle, is equal to my opposite side, which is G, over my hypotenuse, which is 70. Okay, so third step then, of course, is to set up the ratio. And then last step, of course, is to solve. So let's go ahead and solve this. We're going to solve it through cross multiplication. Okay, cross multiplication, I'm going to get G is equal to 70 times sine of 75. So in my calculator, I'm going to go 70 sine 75 and hit equals. And I get 67.6 centimeters, or whatever the units are that we're talking about. So 67.6 is what G is equal to. Okay, let's try another one. So these are like how we always do this. We label our sides, we decide on the trig ratio, we set it up, and then we solve. Okay, so here's my angle down here. So this is my opposite side, and this is my hypotenuse. Whoops, I don't know what I was spelling there. Hypotenuse. And this would be my adjacent side. So I know my opposite. I'm looking for my hypotenuse. I know my opposite. I'm looking for my hypotenuse. Means once again, I am going with the sine trig ratio. So sine of 52 equals my opposite side over my hypotenuse. Okay, let's start. We're still going to cross multiply. So I'm going to get C sine 52 equals 13. 1 times 3 is 13. Then I'm going to divide each side by the sine of 52 to get C all by itself. So C is going to equal to 13 over the sine of 52. 13 divided by sine 52 equals, and I get 16.5. 16.5. Okay, let's try another one. All right, so I want to determine the measure angle of theta and the length of side x. Well, let's start with this angle. If I start with this angle, and label my sides. This is my opposite. This is my adjacent. And this is my hypotenuse. So if I'm going to find this angle, it means I'm going to have to know the two sides. And the two sides that I know are adjacent and hypotenuse. So Sohcahtoa, which one has adjacent and hypotenuse in it? Adjacent and hypotenuse, that would have to be cosine. There's my adjacent and my hypotenuse. So I'm going to say cos theta equals my adjacent side, which is 15, over my hypotenuse, which is 17. Now remember, when you're looking for an angle, we have to get rid of that trig ratio that's in front of it. So I'm going to take the cos inverse of it and the cos inverse of the other side. Because what happens is a cos inverse times a cos cancels out, leaving me with just theta equals the cos inverse of 15 over 17. So in my calculator, remember to get the cos inverse, you're going to have to press second function cos bracket 15 divided by 17 bracket equals. And theta is equal to 28 degrees. Okay. Now, from there, you can still use your primary trig ratios to solve for that missing side. Now that we have an angle, I could use any of my trig ratios, I think, to probably find it. The problem is that, or not the problem, but we don't have to use these trig ratios. If you have two sides of a right triangle and you want to find your third side, remember we can always use Pythagorean theorem, right, to find a missing side if you know the other two sides. So x squared plus 15 squared equals 17 squared. X squared equals 17 squared minus 15 squared, which is going to be 17 squared minus 15 squared is 64. So x equals 8 when I take the square root of each side. So x equals 8. So you didn't have to do any of the primary trig ratios. I mean, you certainly could have. You'll still end up with the same answer. But if you see that you're looking for a third side and you have two of them, feel free to go back and use your Pythagorean theorem. That certainly works well too. Okay. Ooh, so we want to find the missing angles. We're given these three sides and no angles, so that's a problem. The other problem is that our primary trig ratios only work with right triangles. And this is not a right triangle for sure, looking at it. But I do see that this is an isosceles triangle. You may notice we have two sides that are the same, which means that I can take this triangle and I can actually cut it in half. I think that's about right. Cut it in half. And by doing that, it creates these 90-degree angles on each side, and it cuts each of these sides to 2.5. So now what we actually have is this, and I'll take the right-hand side of it. I have two, whoops, let me clean this up a bit. I have 2.5 and I have 6 here. And so they want me to find my angles. I'm going to start, I'll find this angle down here. Now if I label my sides, this is my opposite, this is my adjacent, and this is my hypotenuse. So I want to use the trig ratio that has my adjacent and my hypotenuse in it. Adjacent and hypotenuse is going to be cos. So I can say cos theta is equal to my adjacent, which is 2.5 over my hypotenuse, which is 6. Of course, whenever we're looking for an angle, we want theta to be all by itself. To do that, I want to multiply by a cos inverse, because that will eliminate the cos, leaving me with just theta. Cos inverse of 2.5 over 6. And now I need my calculator again. So I'm going to go shift cos bracket 2.5 divided by 6 bracket equals, and I get 65 degrees. So let me go back to my original diagram here. So that means that this angle right here is 65. And the nice thing is with isosceles triangles, since they have two sides the same, they also have two angles that are the same, which means angle A also has to be 65 degrees. And then to figure out what that other angle B is, I can take 180 and subtract 65, and I think that leaves me with 50 degrees. And so angle B up here would be 50. So by doing just one primary trig ratio and finding an angle allowed me actually to find all three angles inside of that triangle. Ooh, sometimes we might have triangles inside of triangles, which is pretty crazy to look at. So we're asked to find angle theta and we're asked to find side x. To start with, I'm just going to look at the big triangle. So let's take a look at this one here. I'll highlight it, just this great big one right there. And if I do that, I can see that I'm looking for this angle down here. that this is my opposite side, and this is my adjacent side, and of course over here is my hypotenuse. So since I have my opposite side and I have my adjacent side, I'm going to look at Sohcahtoa again because this is a right triangle. Opposite side and adjacent side, that's going to be our tan. So I'm going to say tan alpha equals my opposite side, which is 5, over my adjacent side, which is 13. Okay, so again, I'm looking for an angle. So to look for the angle, I got to get rid of that primary trig ratio in front. So tan inverse, those will cancel out. And alpha equals tan inverse of 5 over 13, which means my angle is going to be, so second function tan, bracket 5 divided by 13, bracket equals 21 degrees. Okay, so the angle right down here is 21 degrees. Now, they'd like me to find side x. So this is what I have. I'm just going to kind of redraw it so that we can see it. So there's my 90 degrees. There's 21. They're asking me to find side x, and this side is 6. I'm going to start by labeling my sides. So this is my opposite side. This is my hypotenuse. And then this is my adjacent. So once again, I'm looking for my opposite, and I have my adjacent. So I'm going to use tan again. I'm going to say tan 21 is equal to opposite over adjacent. I'm going to cross multiply this. X equals 6 tan 21, and x equals 6 tan 21 equals 2.3. So 2.3 centimeters. There. 2.3 centimeters. Perfect. So it's okay, you can have triangles inside of triangles. Again, as long as they have that 90-degree angle, then we can use our primary trig ratios in order to solve this and figure it out. All right, this just takes practice. So go to your worksheet, give it a try, and then if you have any questions, please reach out and ask me. Thanks.